So there's this hard physical limit to HDMI cables that most people don't discover until they're, halfway through an
Oh,
installation.
yeah.
You get about 15, maybe 25 feet of a reliable signal after that.
You hit a wall. It's the classic digital cliff effect. With analog, the picture got fuzzy, a little snowy maybe,
Mm-hmm.
but with digital, the signal just drops.
Black screen,
Nothing.
nothing.
Right.
And today we're looking at the workaround for that specific headache. We're doing a deep dive into the Kramer PT-572 Plus one. It's an HDMI HDCP 2.2 compact receiver. And the mission here is to really understand the tech inside it, this thing called DGKat, and how it lets high-def video travel distances that, well, standard HDMI just physically can't handle.
Exactly. And this isn't just about making the cable longer, it's about changing the type of cable you're using to get around those limits.
Okay, so let's start with the architecture. The PT-572 Plus is a receiver. It's not some standalone booster you just stick in the middle of a long wire. It has to be paired with something.
Right. Correct. Think of it as the catcher's mitt. In a typical install, you'd have a transmitter like Kramer's PT-571 at your source device.
Okay.
That transmitter takes the really heavy, complex HDMI data and converts it so it can travel over a twisted pair cable.
Which is basically your standard internet cabling, like Cat5 or Cat6.
Right. The PT-572 Plus sits at the display end. It takes that signal from the twisted pair, and it just reconstructs it back into perfect HDMI for your screen. And the secret sauce here is that DGKat signal integration.
I was looking into that. It's fascinating because it's not just video. It's converting TMDS, which is the core video data.
The transition minimized differential signal.
Yes, that, plus the control signals, all at once.
And that is the hardest part. Keeping the timing aligned between all that video data and the control signals over long runs of copper is incredibly difficult. If they get out of sync, the image just fails.
The handshake breaks.
DGKat manages that alignment to make sure the handshake between your source and your TV stays totally intact.
So we're swapping out these expensive, thick HDMI cables for cheap, run-anywhere twisted pair. But let's talk numbers. Does it actually solve the distance problem?
Oh, it creates a massive buffer.
Yeah.
If you're running, say, 1080i resolution and you use Kramer's shielded BC Unikit cable,
Yeah.
this unit gets you 90 meters.
90 meters, that's, what, nearly 300 feet?
Roughly 295 feet.
Yeah, that's practically a football field. But I did notice in the specs that the range drops if you bump up the resolution to 1080p.
It does. At 1080p, the data density is much higher, so the reliable distance drops to about 70 meters. So 230 feet.
Still very impressive, but that 20-meter drop is pretty significant if you're planning a tight run.
It is. But if you upgrade the cable itself to something like the BC DGKat 7023, you can push that 1080i signal all the way to 100 meters.
Wow, okay.
The device itself maxes out at a data rate of 4.95 gigabits per second. That's the ceiling for how much info it can reconstruct without issues.
So the lesson for you, the listener, is don't just look at the receiver box specs. You have to look at the cable grading you're pairing with it.
100%. The quality of the copper dictates the range just as much as the electronics do.
Now, for the physical installation, I'm looking at the diagrams, and this thing is part of their Pico Tools line. It's tiny, about 6 centimeters wide.
Very small. And that's for two reasons. One, it's super easy to hide behind a flat panel display. But two, for server rooms, you can get a rack adapter and slot 4 of these units side by side in a single 1U rack space.
That density is huge for big commercial setups, but I think my favorite feature in the notes is Power Connect, or
Power over cable. That is a huge convenience for installers.
it feels like a game changer, because usually behind a TV, you're fighting for power outlets. You don't want to have to call an electrician just to plug in a little receiver box.
Precisely. With PTC, the whole system runs on 12 volts DC. You plug the power adapter into the transmitter end, say, in your rack room, and it sends the electricity down the CAT cable along with the video.
So the PT-572 Plus receiver at the other end doesn't even need its own plug.
It just wakes up when the transmitter sends power. It simplifies the endpoint dramatically. And it does all this while maintaining full HDCP compliance and 3D pass-through. It's designed to be totally invisible.
That seems to be the theme here, doesn't it? It's digital plumbing. We obsess over the 4K screen or the flashy projector, but without this little gray box in the wall, none of it even works.
It really is the backbone of modern AV. Think about airports, sports bars, conference centers. They all rely on this kind of conversion to function.
It definitely changes how you look at a simple screen on a wall.
So before we wrap up, here's something to mull over. We rarely think about the physical journey a single pixel takes to get to our eyes.
Mm-hmm.
The next time you're in a stadium or an airport and you look up at one of those giant displays, just ask yourself, How many invisible conversions and how many miles of copper wire did that image travel through just to look seamless the moment it hit the glass?
Thanks for listening to the deep dive.